So, today we are starting a new unit. We took our quiz on Tuesday on complex numbers. Today we are starting the discriminant, which is a part of the quadratic formula. The quadratic formula is a way to solve quadratic equations that cannot be factored. So, quadratic formula is a way to solve quadratic equations that cannot be factored. So, let's go over the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. So again, here's the quadratic formula. It comes from standard form. So a quadratic equation in standard form is ax squared plus bx plus c. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, you will need to have that memorized. So you need to know standard form as well as the quadratic formula. All right, so what is the discriminant? The discriminant is the part under the radical. So that's why it was so important to understand how to simplify radicals in 5-4. So what is the discriminant? The discriminant is the piece under the radical. It is b squared minus 4ac. It helps us to determine the number and types of solutions in a quadratic equation. It helps us to determine the number and types of solutions in a quadratic equation. Okay, so the discriminant tells us the number and types. Do you still need the other slide? You know I typed up the bottom paragraph, right?
Oh.
That's why when you asked me to go back, I was like, all you had to write down was b squared minus 4ac. Yeah, Alright, so describe the number and type. You can describe the number and type as one of three choices. If the discriminant is positive, then you have two real roots. If the discriminant is positive, you have two real roots. If the discriminant is negative, then you have one real root. If the discriminant is negative, then you have one real root. Sorry, I meant to say 0. If the discriminant is negative, then there are two imaginary roots. Imaginary involve I. If the discriminant is negative, then there are two imaginary roots involving an I. All right. So, in example number 1, it says, find the discriminant value, then determine the number and types of solutions. So, to find the discriminant value, what you are going to do is you are going to make sure it is in standard form. Once it's in standard form, you are going to take the A, which in this case is 1, B, which is -2, and C, which is 4, and plug that in to the discriminant, which is B squared minus 4 times A times C. So remember, order of operations is exponents first, so -2 squared is 4. And then you have to multiply before you subtract. So 4 times 4 is 16. So 4 minus 16 is -12. A -12 implies 2 imaginary solutions. All B squareds must be positive. So if you're typing this in on a calculator, what you would want to do is on your calculator, put parentheses around the number. So parentheses here on the calculator, and then parentheses around everything being multiplied. So on your calculator, when you type the middle part, you would type 4 times 1 times 4. And then that would give you your -12. In order to find the discriminant, once again, it must be in standard form. To be in standard form, it must be set equal to 0, not a number. So we have to first start by subtracting 1 from both sides, so that this is now set equal to 0. And then you're going to identify your A, B, and C. And then you're going to just take those values, plug them into the discriminant. So it's B squared minus 4AC. So 4 times 3 times -1 is -12. So I get a negative and a negative, which is really like a positive. So it's 25 plus 12, or 37. The discriminant is now positive, so that implies 2 real roots. Okay, so in this one, once again, you need to get it set equal to 0. It doesn't matter which direction you move the 0. So you could have -x squared minus 10x minus 25 equals 0. Or you could have moved everything to the right side and had 0 equals x squared plus 10x plus 25. So these are equivalent equations. They'll get the same roots. You'll have the same discriminant. It's just one set equal to the left and one set equal to the right. So once again, your discriminant is b squared minus 4 times A times C. And we get a discriminant value of 0. A discriminant of 0 tells me that I only have one real root. And if you reflect on graphing a quadratic, what that means is that in factored form, this would look like x plus 5, x plus 5. And you can see that we get the same root twice. So that's why your discriminant is 0. That's why you only get one real. And this is what we call a repeated root. And that means that your root is the vertex, which is on the x-axis. I may or may not have an answer.
Why is there a 10 in the parentheses? Not like a 1?
Because the 10 represents the b value, and in this case, the b value is 10.
Yeah, I get that, but like, why is the a value not there?
The a value is right here.
I thought I had to go front. Oh, how confused it.
It's 4AC, so the 4 goes in front, which is the A. I mean, the A is the 1. The 4 is part of the equation. It's b squared minus 4AC. Yeah, Colton, what's up?
I didn't see the AC part. I got thrown off. Did you do it with the negative 10 and the negative 25? I think I missed something.
Yep. So if you do it with the negatives, let's go through and do it that way. So negative 10 squared is a positive 100. And then a negative times a negative times a negative. Did you forget the negative 1?
Yeah, I did.
Okay. So like I said, the discriminant can describe the number of x-intercepts. That's what I was just showing you on that previous example. So if you recall, we have roots, solutions, zeros, x-intercepts. All of these words are very similar. The roots / solutions always come as x equals. That's why the quadratic formula is x equals. That's why when you factor, your answers are x equals. The zeros and x-intercepts are the same thing, but these will come as points on the graph. And they will always have y equals 0. So the zeros or x-intercepts will be coordinate points. With y equals 0. So the discriminant tells us how many and what type. The roots and solutions for zeros and x-intercepts both represent the same thing, just different ways of writing it. So for example, here it says find the number of x-intercepts. Again, they represent the roots or solutions. So what you would do is find the discriminant of that. So you get a discriminant value of 24. All we care about is the sign. So since the discriminant is positive, that tells me I have 2 real x-intercepts. We know how to find these because we know how to factor. Now, if we look at this one, is that factorable? Are there factors of 3 that sum to 6? The answer is no. So that's where tomorrow's lesson is going to come into play. We could, however, graph this real quick and see our x and y intercepts. So remember, this represents the y-intercept. The axis of symmetry is negative b divided by 2a. So in this case, negative 6 divided by 2. So it tells me that this graph is symmetric. Through that line there. Yes. I got a new pen for like the iPad, so I'm still getting used to writing with it. I think it writes nicer, I'm still learning it. Okay, and then you take that number and you plug it back in if you recall that. So we get negative 3 squared plus 6 times negative 3 plus 3, and that will give me the value of the vertex. So there's my graph. So we can see and or recall, if you remember from lesson 5.2, the roots or solutions are where the graph crosses the x-axis, and I can see that this crosses twice. So the discriminant gives me that same piece of information that we got from graphing. So the discriminant's just giving me that information we got from graphing. Okay, let's look at 2 more. So we're going to find the discriminant. So you get b squared minus 4ac. So in this case, you get 36 minus 40, which is negative 4. So that tells me that this has 2 imaginary. And that tells me that I have no x-intercepts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'll find your vertex. So it's symmetric through negative 3 again. But this time the vertex is at negative 3, 1. So what you notice is the graph never hits the x-axis, therefore no x-intercepts. Yep.
What was the formula for K?
It's taking the h value and plugging it in. So like all I did,
So you just plug it in for everything?
you plug it in for x in the equation given to you.
Okay.
Yep. Last one. B squared minus 4ac (36 minus 36 is 0. So that tells me I have one real or one x-intercept. This one is in fact factorable, so now, since it's factorable, you don't have to do the b squared minus 4ac, the negative b over 2a, but we can. So we get negative 3 again. But this time, when we plug negative 3 in, we get 9 minus 18 plus 9, which is 0. So what that does is that tells me that my vertex is on the x-axis and that represents my one x-intercept and one real root. Remember, this is your y-intercept. It's 0, c. So in this case, it was 0, 9. So just bringing everything sort of back into play, because we will have a chapter test. There's only this unit really left of chapter 5. So that's why as I go back into this unit for chapter 5, I start to reintroduce everything we did at the beginning of chapter 5. So 5, 6 is the last lesson of chapter 5. Your homework is that next page in your packet. You're finding the discriminant. So you're going to describe the number and types of roots. You're doing the front and the back. You have about the next 15 minutes in class to work on that. Yes. Kind of. What do you need from it? This one? Okay. Give me 1 second. Let me go to it on the video.